Yeah, excuse me. Hey guys, we're going to be doing 4.5 today. So if you guys could please have your notes out and follow along as we do this together. So 4.5, it says, in our work so far, we have worked with linear equations in many forms. Some of the forms of the equations and their names are here. So what we've done is we've looked at recursive form. And as you remember, recursive form is when we have the previous term, and what we are trying to do is figure out what we do to the previous term to get to the next term. So right here, it's telling us that we are starting with the numerical value of 1, and what we are going to do is add a half to that each and every time. Okay? And we can actually convert this, so since I know f of 0 is 1, I know that's my b value, and I know since I'm adding, since it's linear, that's my slope of 1/2. So I actually know this equation is y equals 1/2 x plus 1. Now this over here is slope-intercept form. Slope-intercept form, as a quick reminder, is you're given the slope and the b value. So this is y equals mx plus b. That's pretty straightforward here. The next one is point-slope form. We've been exploring this the past few lessons. This is when you are giving the slope in an ordered pair. Here I would have been given the ordered pair 4, 3, and I plugged it in here. Now remember, anytime I simplify this, it should equal the slope-intercept form. So if I were to distribute this, I would get y equals 1/2 x minus 2 plus 3, which would then simplify to y equals 1/2 x plus 1. Same as the other ones. One we haven't looked at since 8th grade is, since Math BH is standard form. Standard form is used to find 2 and only 2 points. These two and only 2 points are the x and y intercept. So if you plugged in 0 for x, you could solve for y. If you plugged in 0 for y, you could solve for x. But same idea, I can convert this into slope-intercept form by subtracting x on both sides. This would give me negative 2y is equal to negative x minus 2. And when I divide each and every term by negative 2, this would give me then y equals positive 1/2 x plus 1. So explain how you know how all the forms represented above are equivalent. So that's why I was go ahead and solving these up above here. You basically can convert them all. You can convert them all into any form, but we converted all these into slope-intercept form. So let's go ahead and write that. When we convert each equation into slope-intercept form, they will reduce to the same equation. And that's how I know that they're equivalent. Okay, so it doesn't matter what form it is, whether it's standard, point slope, slope-intercept, or what we learned this year of recursive form. They're all different ways to write the same equation. Okay, so now what we're going to do is focus on the context of these. It says context investigation, which form best tells a story. So what you're going to do here and on your test is I'm going to give you a scenario and you're going to tell me what form best represented. Is it better to write it in standard form or is it better to write it in slope-intercept form? Excuse me. So you you have been appointed a mathematics efficiency expert. Your job is to compare the forms of linear equations for different uses and decide which form is most efficient and effective for each use. So determine which form will be most efficient and effective for the scenario. So in his job selling vacuums, Joe makes $500 each month plus $20 for selling each vacuum. So you need to decide, based off this story, which form best represents this story. And in my opinion, it would be slope-intercept form because it shows his base salary of $500 a month plus his commission of $20 per vacuum that he sells. So the Tree Hugger Granola Company trail mix with candies and nuts. The cost of candies for a trail mix is $2 per pound. plus nuts is $1.50 per pound. The total cost of a batch of trail mix is $540. Well, based off that scenario, would it be better to represent that in standard form or slope-intercept form? And in my opinion, since it's talking about the cost of nuts and the cost of granola, and the total cost has to be equal to 540, standard form would be the better scenario. So let's go ahead and look at these figures. It says Grandma Billings is working on working on a quilt with blocks in the following pattern. So here we have 1, 2, 3, 4, 5, 6, 7. Oops, 1, 2, 3, 4, 5, 6. Yes, so we have 7, then 13, then 19. And we need to decide, is this better for slope-intercept form or recursive form? And I guess there is an argument for each one, but based off of this, it says we can have an answer of 7, an answer of 13, and then an answer of 19. So based off that, I would actually choose recursive because it's saying to get to the next term, I need to add 6 to the previous. Slope-intercept form, while it does look very similar, this would be a continuous graph and you can plug any numerical value in for n. But here we're only looking for 7, 13, 19, so on and so forth. So our answer there would be recursive. Now a pool is filling at a constant rate of 5 gallons per minute. After 13 minutes, there are 500 gallons in the pool. So we're given the slope and we're given a point, 13, 500. So based off that, our solution would be point slope form. And there you go. So this will be on your test coming up, so make sure we understand these. And now what we're going to do is equation investigation. We're going to create an equation based off the information that they're given to us. And we're going to have to basically create the form. So determine which of the 4 forms of the linear equation to use to write each equation. So once again, we have slope-intercept form, point slope form, recursive, and standard form. And you need to figure out which form should we use. So it says write an equation with a slope of -2 and a point of -2, 5. So right there, I would want to use point slope form because they give us a point and the slope. So right here, it would be y equals -2x, -2 parentheses, x minus -2, so that turns to x plus 2, plus 5. So the order pair is -2, 5. When you plug it in here, when you take away a negative, it turns to a positive. Now it says, write an equation of a line that passes through the point 1, -2 and 4, 1. Well, from here, what we would want is to find the slope. So if we remember the equation with Miss Griffin, stack them, subtract them, y over x, If you guys remember that song, that's great. If not, we can just use this equation, y2 minus y1 all over x2 minus x1. So when I look at this, I will have 1 minus -2 all over 4 minus 1. When I take away a negative, this turns to a positive, so I'll have 3 over 3, which reduces to 1. So that's my slope. And now, over here, I guess we could use point slope form, or we can solve for b. Either way doesn't matter. I think it's a little quicker to do point slope form. So if I use my slope, y equals 1 parentheses, and then x minus 4 plus 1, that would be the most efficient. You could simplify this to slope-intercept form if you choose to get y equals x minus 4 plus 1 to get y equals x minus 3. So in my opinion, either slope-intercept form or point slope form would be the acceptable answers for that one, depending on how you'd like to solve it. Now it says write an equation of the arithmetic sequence that starts at -7 and decreases by 3. Okay, so to do this, what we're going to first do excuse me. So it says I'm going to start off with 1. So really quickly, we have to write one of these four equations. And if we're starting off at -7 and we're decreasing by 3, that looks like recursive to me. So it's saying we're going to start off, so f of 1 is equal to -7. From there, to get to my current term, I'm going to look at my previous term, and I'm going to decrease by 3. So that is my recursive. Just to make sure, sequence that starts with, you could have also written f of 0 equals -7, since it didn't tell you exactly what the first term was. So now we're going to take this idea. We've looked at context, we've looked at writing the equations, and now we're going to just do a quick reminder of graphing these. So when we have slope-intercept form, all we do is we start with the slope, we start with the y-intercept. The y-intercept is 5. So we're going to go to +5. And then we're going to add more points by using the slope by going up 1, 2, 3 over 1, 2, 3, 4. And if I wanted an additional point, I could also go down 1, 2, 3, and to the left 1, 2, 3, 4. From here, we can go ahead and draw our line. Oops. Switch that to the straight line. And there we go. It says, how does the slope-intercept form assist you from completing the graph? Now in slope-intercept form is we always start with the y-intercept, then add additional points with the slope. Okay. Next one, standard form. Like I said before, standard form is used to find 2 points. It's used to find the x and y intercept. And we do that by plugging in 0 for x and solving for the y-intercept. Then we plug in 0 for y and solving for the x-intercept. So if I looked at this, we could start with the x-intercept to get 3x minus 5 times 0 equals 15. This would give me 3x equals 15, which means x equals 5. So when I plugged in 0 for x, 0 for y, I got 5 for x. So that's my first ordered pair. The second one, we're going to plug in 0 for y. 0 for x and solve for y. So 3 times 0 minus 5y is equal to 15. Negative 5y is equal to 15. When I divide by negative 5, we'll have y equals negative 3. So when I plugged in 0 for x, I got y as negative 3. So here's my other ordered pair, solving with standard form. And then we can connect these. And there's my second equation. So how do we use standard form to graph? So in standard form, we solve for the x and y intercept by plugging in 0 to the equation, 0 into the x and solve for y, then plug in 0 for y and solve for x. Okay. Now we have point-slope form. In point-slope form, we need to identify what the point is. And it's always this opposite. So this is +6, so that's my x value. It's actually going to be -6, comma, +5. So we're going to start by plotting that point of -6, comma, +5 right here. And then we're going to use our slope of -4 to find additional points. So from the point that's on the graph, we're going to go use our slope of going down 4, 1, 2, 3, 4 over 1, down 1, 2, 3, 1, 2, 3, 4. I can't count. 1, 2, 3, 4 over 1. I think I got that. You could also gone up 1, 2, 3, 4 over 1 as well. So here we would go ahead and graph our line like that. So let's go ahead. How do we do that? So in point slope form, we graph the ordered pair first. And to find additional points, we use the slope. All right, this one's recursive. Recursive's a little different just because it's from one stage to the next. So this is going to be a discrete graph. And what this is telling me is f of 0. So when I plug in 0 for x, my output is -2. That's my y-intercept. And then to get to the next term, I'm just going to minus 5. So when I have 1, I'm going to minus 5 over here. And I don't even think you would go up to the left because it tells me my first term. So to be honest, I think we'd be done here. You wouldn't draw a line because it's recursive. So what I would have done, I would have had a different example where I could have added more points. But regardless, this is what our graph would look like here. Okay, so really quickly, how does recursive form assistance? So first off, we start with the first term, which is usually f of 0 or f of 1. Then we use the slope to plot additional points, which will be shown as plus or minus a number. And then these are going to be discrete graphs. Okay. So this is all the linear equations. These are all the linear stuff. So we've looked at point slope form, slope intercept, recursive, and standard form. And now what we're going to do is we're going to take the same idea and we're going to look at exponential. So we've looked at exponential. Exponential is, it goes up at an exponential rate. And they had recursive, so f of a is equal to b, so that's, my initial value. And there it has a common ratio, so we're going to multiply. So right here it says when I plug in 1, I'm going to start off at 6. And to get to my current term, I look to the previous term and I multiply it by 3. And then from here, in explicit, it's y equals b to the r x minus a. This could be represented as y equals 6 parentheses 3 to the x minus 1. Or since 6 can be broken down to 3 times 2, you could then combine the 3's to get y equals 2 times 3 to the power of x. Okay. So what we're going to do is determine which form of the equation will be most efficient and effective for this scenario. Grandma Billings has started her quilt squares, her quilt together, and created the following growth pattern. So let's see this. This is 1, 2, 3, 4, 5, 6, 7, then 14, and then 28. So to get to one term to the next, we're doubling it, and we started off at 7. So this sounds like recursive to me. All right, so the population of a resort of Java Hot Springs in 2003 was initially 35,000 people with an annual rate of increase of 2.4%. Which of the following models represents the people of Java Hot Springs, with T being the number of years since 2003? And I would say this is explicit. You started off with 35,000, and it's increasing by 2.4%, so that would be 1.024 to represent a positive growth. Now it says graph the following describe how each representation of the function. So let's go ahead now and start with this. We're going to graph this. They give me a base of 1.8. And from 1.8, what we are going to do is we're going to basically just double it. So let's see. From here, I think these are my x and y axes. I think we can just go up by ones. So this is 1, 2. And now I need to find my initial value. So if I plug in 0, 1.08 to the 0 power is 1, and 1 times 2 is 2. So that's my first ordered pair. The next one, 1.8 to the first power is 1.8 times 2 is 3.6. So that would be right here. I'm going to grab a calculator out to do the rest of these now, because I don't know these off the top of my head. So now we're going to do 1.8 to the second power, which is 3.24, times 2 is 6.48. So when I plugged in 2, I'm going to get 6.48. Okay, let's do a few more. We'll do 1.8 to the third power. That is 5.832. And when we double that, we're going to get 11.6. It's 11.664 to be exact. And I think we can fit one more in here. Let's do 1.8 to the fourth power. So that will give me 10.497. And then we're going to double that. We'll get just above 20. So when we plug in 4, it'll be just 20.995. So we'll put it about right here. So how does the explicit form assist you from completing? So all we need to do is plug in numerical values. Plug in values for x and solve for y. Our initial value will be our y-intercept when it is just x. So not like x minus 1 or x minus 2, just x. Okay, how does the recursive form assist in completing this graph? So in recursive, it says we're going to start off at 5 and we're going to have a decay. And each one we're going to be going down by 0.6. So we're going to retain like 40% of our value. So when I look at this, if I go up 1, 2, 3, let's go up by halves. So half, 1, there we go. So this is half, 1, 2, 3, 4, 5. Okay. So when I look at this then, it says we're going to start off at 5. And I'm going to multiply it by 0.6. This will give me 3. Oops, let me plug in these values. And then I'm going to take the 3 and multiply it by 0.6. That will give me 1.8. Take that 1.8, multiply it by 6. That'll give me about 1.08. Multiply that by 6, get 0.648. And then we're going to multiply that again by 0.6 to get 0.388. And let's see if we can do it one more time. To get like 0.2. Now since it's recursive, it's going to be a discrete graph. And all we're going to do here is how it is recursive. It's like we start with our initial value and we multiply it by the growth factor each stage, or the common ratio. Okay. Now this last part is explain how you know that the forms presented below are equivalent. So this one's a little different. It's a little trickier. And what this is saying is f of 2 equals 8. And I'm going to take the previous term and multiply it. So since I'm given a point of 2, 8, and I am saying I have a ratio of 4, I can plug this into the point ratio form. The point ratio form would be f of x is equal to 8 times 4 to the x minus 2. From there, I know that this is well, let's pause right here. So from here, I can tell when I plug that in that the first and the second are equivalent. Okay? So I'm going to manipulate these again in a second, but I want to look at this third one now, because this is saying f of n is equal to 1/2. And if I wanted that 1/2 to become on the numerator, that 2, this would be 2 to the negative 1. And then I would have times 4 to the n. Now when I look at that, I can't combine them at the moment because they don't have the same basis. So I need to turn this to 2 times 2. So I'm going to have 2 to the negative 1 times 2 to the second to the n. And when I have a power to a power, I multiply. So this will be 2 to the negative 1 times 2 to the 2n. And when I multiply bases, I add and subtract the exponents to have 2 to the 2n minus 1. So I need to try to convert these now over here. And I only need to do it to one of them since they're both equivalent. So I know that this right here, 8, is 2 times 2 times 2, which is 2 to the third power. And I know that 4 is 2 to the second power. Two to the second power, and then I already have the exponent x minus 2. So when I have a power to a power, I multiply. So I don't do anything with 2 to the thirds. Now I would have 2 to the 2x minus 4. And now that I have the same bases, I'm going to add them. So this is going to give me 2. I can't do anything with the 2x, so that stays the same. And 3 minus 4 is negative 1. So there you can see that these are equivalent. And once again, since I started off with the same one here, I did not need to resolve that one. Alright guys, so that's the video lesson for today. I hope that was helpful. You guys can now work on RSG 4.5, and hopefully I'll feel better and see you on Monday. Have a great day, guys.